Hey everybody, Vade here. Today we're going to be doing another geometry need for calculus problem. Today we're going to be finding the heights of rectangles. Now before that, I just want to, sort of acknowledge something here. So of course the authors of this book here that I'm getting the problems from. If you've been watching the previous videos, you already know I've talked about these guys a lot, Ron Larson and Paul Battaglia. They included the integral symbol here, right, indicating that this is like, hopefully integral symbol has to do with calculus. Now, again, I think I know why they like purposefully added the integral symbol, because they shaded in these regions here. Okay, they shaded in these regions, and I think why they shaded in these regions is to sort of emphasize that the areas of these regions can have to be computed using calculus. They can only be found using calculus. Hopefully, if you think about this here, the area between these two functions here, right, you cannot use, or you don't know, like a geometric formula that could be used to actually compute this area, right? Like in geometry class, you didn't learn how to find the area between two curves, and that's because you need to know calculus in order to do that. You need to know, integration, because integration deals with finding areas, right? As you will learn in calculus. Now, again, this will be in quite a while, because you will first have to learn limits, derivatives, and then you will learn integration. But it's sort of cool to mention, like, you can find areas between functions in this case, and you can also find again areas like under the curve of a under the curve under a certain function. So it's this is sort of introducing you to the ideas and concepts related to integration. And you're probably like, well, what's so significant about finding the area under, or between two curves? And that will really be evident when you actually apply integration. So when you do application problems. So I don't want to get too into that. But really, a lot of stuff that we do, in the world today could not be possible without, finding these areas and using integral calculus. So just really good to mention here that it is possible to find these areas. It is not impossible. Okay, we use something called calculus. So cool. Let's find the heights of these rectangles. So again, it kind of is tricky at first. Like, it confuses the heck out of you, maybe. Like, how do I approach this? So I think that Ron and Paul, they're given decent hints here. So this is the curve, y equals 4x minus x squared, right? It's given to us. This curve is y equals 4x minus x squared. That is a fact. And this line is y equals 3. Why? Because we are given this point 1 comma 3. So this line right here must be y equals 3. Okay, so this is y equals 4x minus x squared, and this is line y equals 3. So really nice of Ron and Paul to sort of give you this dashed sort of line here and an x. Okay, so what does this represent? Well, we can sort of see here that we can find this point corresponding to this x. Okay, so we can find this point corresponding to this x. Well, you're probably, Vade, how do we find this point corresponding to this x right here? Well, we're inputting x, right? We're inputting x. Then our output must be 4x minus x squared, right? Another way to think about this is, right, like with this curve, we know that x comma y will belong on this curve y equals 4x minus x squared. We have an x is x, but then y, well, y also equals to 4 minus x squared, so x comma y is really x comma 4x minus x squared. Alright, now, can we use the same logic with y, the line y equals 3? Sure we can. Now you're probably like, why would we need to do that? Well, if you think about this, if we find this point right here, the distance between these 2 points will actually give us our height. Now, again, I do not want to bring up distance between 2 points because then that'll tempt you to use the distance formula. And while, yes, you will get the same answer using the distance formula, it's a lot of additional work because you see here that this is really just the distance between the y values, right? Because x will still be the same for this point right here, right? Agreed, right? X will still be the same for this point, okay? But then the difference is that y, instead of y equals to 4x minus x squared, this will be, and let me find a better way of labeling this here. This line will be, this horizontal line here, will be y equals to 3. So instead of x comma y, we can write x comma 3. So now we just need to find the distance between the y values. So that'll just be this y value, right? This y value minus this y value. So it'll just be h equals to 3 minus 4x minus x squared. And that's our answer. Hopefully that makes sense. Alright, let's begin with the next problem here. We see the same similar layout here. We're given the equation of this line here, and we're also given the equation of this curve here. So very similar setup, and guess what? The process is also the same. We want to find this point. This point would be x comma y, but it's also just x comma 2x. This point right here, this will be x comma y, but y equals to 4x minus x squared, so it'll be 4x minus x squared. We want to find the distance between the y values, so it'll just be this y value minus this y value. So it'll just be h equals to 4x minus x squared minus 2x, which will then further equal to 2x minus x squared. So these are our two answers. Hopefully the logic makes sense, right? We know that, right, if we have y equals to 4x minus x squared, x comma y must belong to this function right here. Same thing here, right? We have like y equals 3, right? And this would be times 0x, right? X comma y must still belong here. We have y equals 2x. X comma y must belong here. We have y equals 4x minus x squared. Well, we already did that. You guys get the point, right? X comma y must belong to both of these. But hopefully you realize here that these y's, when we are talking about these y's right here, yes, we are referring to these y's right here, right? We are referring to these y's right here, okay? Because that output would be 2 times x. That output would be 3 times 0x. That output would be 4x minus x squared. Okay, so really, input, output. Okay, not that difficult. Alright, I'll see you guys in the next one.